Hello viewers, welcome to my channel Learn Electrical Engineering 121 Pod.
Hello viewers, in last session we have seen force voltage and force current analogy. Today we'll try to solve a problem regarding force voltage and force current analogy and get the equivalent system. This mechanical system we have to write the differential equation, then try to get the equivalent system in terms of electrical parameters. Start with, we'll get the free body diagram first for the node 1 M1. On this, where the input is f of t and here the output is x1. In terms of velocity, it's nothing but v1 say. Now here the opposing forces are due to m1 and then you have b1, and then in common you have b12 and k12, f b12 and then you have f k12. Applying the condition, sum of the opposing force is equal to applied force. F m1 plus f b1 plus f b12 plus f k12 equal to f of t. Substituting the equivalent terms, we get m1 d square x1 by dt square plus b1 dx1 by dt plus b12 d by dt of difference of the displacement x1 minus x2 plus k12 into x1 minus x2 equal to f of t. We are supposed to convert this in terms of displacement to velocity, because we have seen in the earlier session, if it is force voltage analogy where input is the force in mechanical system, then output would be in terms of displacement, say for example, and that is, or else in terms of velocity. Velocity is nothing but, in terms of electrical system, it is nothing but current. So if input is the voltage, output would be current. You are supposed to, in order to get the equivalent electrical system, you are supposed to convert this into force and velocity. In terms of velocity, output should be in terms of velocity. For that reason, we'll convert this in terms of displacement to velocity free. See, for example, d square x by dt square equal to dv by dt. It's nothing but dv by dt. And dx by dt is nothing but velocity. And from that we get x is nothing but integral v dt. Now with this, we'll try to convert this into, in terms of velocity parameter, m1 dv1 by dt plus b1 plus b12 b1 minus b2 plus k12 into integral v1 minus b2 dt equal to f of t. Equation 1. So this is our first differential equation. We'll get the free body diagram and write the differential equation for node 2. Output is nothing but in terms of displacement x2, in terms of velocity v2. Opposing forces are due to m2, k2, b2, k12 and b12. F m2, f b2, f k2, f b12 and f k12. Now applying the condition, f m2 plus f b2 plus f k2 plus f b12 plus f k12 equal to 0. m2 into d square x2 by dt square plus b2 into dx2 by dt plus k2 into x2 plus b12 d by dt of x2 minus x1. Now plus k12 is nothing but k12 into x2 minus x1 in terms of velocity frame here. m2 into dv2 by dt plus b2 into b2 plus k2 into integral v2 dt plus b12 into b2 minus b1 plus k12 into integral b2 minus b1 dt. Second differential equation. With these two differential equations, we are supposed to go for force voltage analogy and get for force voltage analogy, force is the input, then voltage is the input. Okay. Now if velocity v1 is the output here, then I1 is the output here. Likewise, if it is b2 here, velocity, then I2 is the output here. And here m is replaced with L, then b with R, and then k with 1 by C. Obviously from these two differential equations we can easily find out what are the elements linked up with only node 1 and what are the elements linked up with only node 2 and what are the common elements in between node 1 and node 2. Number of nodes in the mechanical system would represent number of meshes in this. Obviously you do have two meshes here, and here we will be applying KVL. In common elements we do have K12 and B12. K is replaced with C and B is replaced with R. R12, that is B12 in common, and then B12 E of t. Node 1, M1 is replaced with L1, L1, B1 is replaced with R. Only with node 2 we have M2, that is nothing but L2. Only with node B2 and K2. B is nothing but R2 and this is K is nothing but C. Okay, now I2. This is the equivalent system for this particular mechanical system in terms of force voltage analogy. Now again from this we are supposed to write the differential equations, KVL, and then see the resemblance between these two equations. Applying KVL for the first loop, we get L1 di1 by dt plus R1 I1 plus R12 I1 minus I2 plus 1 by C integral I1 minus I2 dt equal to E of t. Make this as equation 3. This is C12. Write the equation for the second loop. L2 di2 by dt plus R2 I2 plus 1 by C2 integral I2 dt plus R12 into I2 minus I1 plus 1 by C12 integral I2 minus I1 dt equal to 0. Let's make it as 4. Now if you can observe, equations 1 and 2, 3 and 4 do have the resemblance. These are the equivalent terms for this mechanical differential equations. Do you have any queries and suggestions? Please comment in the comment box below.
Thank you for watching. If you find this video helpful, please like, share and subscribe. Stay tuned for more videos.